Concept of chemistry. Introduction. Chemistry is the study of matter, its physical and chemical properties, and the physical and chemical changes it undergo under different conditions. Matters is divided into two parts, which is pure substance and mixture. Mixture is divided into two parts, homogeneous, heterogeneous. Pure substance is divided into two parts, elements, compounds. Elements is divided into metals, nonmetals, metalloids. Chemistry is a central science. Its knowledge is required in the studies of physics, biological science, applied science, and the earth and space science. The scope of chemistry is in every aspect of life. For example, the air we breathe, the food we eat, the fluid we drink, our clothing, transportation and fuel supplies, and so on. Though it is an ancient science due to development and advancement in science and technology, chemistry has developed as modern science. Technological development in sophisticated instruments expanded our knowledge of chemistry, which now has been used in applied science such as medicines, dentistry, engineering, agriculture, and in daily home use products. Nature of chemistry. Chemistry is traditionally classified further into five branches: organic, inorganic, physical, bio, and analytical. Organic chemistry is the study of the properties and reactions of a compound of carbon. Inorganic chemistry is the studies of all substances which are not organic. Physical chemistry is the study of principle underlying chemistry. It deals with studies of property of matter. It is study of atoms, molecules, and fundamental concepts related to electrons, energies, and dynamic therein. It provides basic frameworks for all the other branches of chemistry. Let us understand first what are pure substance and mixture. Pure substance versus mixture. Pure substance have a definite chemical compositions. 1 2.1 Matter. You have learned earlier that matter occupies space and has mass. Matter can be further classified into pure substance and mixture on the basis of chemical compositions. Let us understand first what are pure substance and mixture. Pure substance versus mixture. Pure substance have a definite chemical composition. They always have the same property regardless of their origin. Mixture have no definite chemical composition and hence no definite property. Example of pure substance: pure metal, distilled water, etc. Example of mixture: paint, mixture of oil, pigments, additive, concretes, a mixture of sand, cements, water. Can you tell which are mixture and pure substance from the following? First, seawater. 2, gasoline. 3, skin. Fourth, a rusty nail. Fifth, a page of the textbook. And sixth, diamond. Pure substance are further divided into elements and compounds. Elements are pure substance which cannot be broken down into simpler substance by ordinary chemical changes. Elements are further classified as metal, nonmetals, and metalloids. Metals. First, first point: have a luster or shiny appearance, conduct heat and electricity, can be drawn into wire or ductiles, can be hammered into thin sheets, are malleable. Example: gold, silver, copper, iron, mercury is a liquid metal at room temperature. Non-metals. First point: have no luster. Exception: diamond, iodine. Second are poor conductor of heat and electricity. Exception: graphite. Third, cannot be hammered into sheets or drawn into wire because they are brittle. Example: iodine, nitrogen, carbon, etc. Metalloid. Some elements have property intermediate between metals and nonmetals and are called metalloids or semi-metals. Example include arsenic, silicon, germanium. Compound are the pure substance which can be broken down into simpler substance by ordinary chemical changes. In a compound, two or three elements are combined in a fixed proportion. Mixture contain two or more substance is no fixed proportion and may be separated by physical method. Mixture further divided into homogeneous and heterogeneous. Solution of homogeneous mixture become because the molecule of constituent solutes and solvent are uniformly mixed throughout its bulk. In heterogeneous mixture, the molecules of the constituent are not uniformly mixed throughout the bulk. For example, suspension of an insoluble solid in a liquid. 1.2.3 States of matter. You are also aware that matter exists in three different states, namely gas, liquid, and solid. We are going to learn about these states in Unit 3, Chapter 10. In solid, constituent atoms or molecular particles are tightly held in a perfect order and therefore solid possess definite shape and volume. Liquid contain particles close to each other and they can move around within the liquid, while in gases the particles are far apart as compared to those in liquids and solid states. Three states of matter are inconvertible by changing the condition of temperature and pressures. Classify the following as elements and compound. Mercuric oxide, helium gas, 3 water, fourth table salt, fifth iodine, sixth mercury, seventh oxygen, eighth nitrogen. 1.3 Property of matter and their measurements. Burning of magnesium wire. Different kind of matter have characteristic property which can be classified into two categories as physical property and chemical properties. Physical property are those which can be measured or observed without changing the chemical composition of the substance. Color, odor, melting point, boiling point, density, etc. are physical properties. Chemicals property are the property where substance undergo chemical change and thereby exhibit change in chemical composition. For example, coal burn in air to produce carbon dioxide, or magnesium wire burn in air in the presence of oxygen to form magnesium oxide. Measurement of properties. Many properties of matter are quantitatively in nature. When you measure something, you are comparing it with some standards. The standard quantity is reproducible and unchanging. Many properties of matter such as mass, length, area, pressure, volume, time, etc. are quantitative in nature. Any quantitative measurement is expressed by a number followed by units in which it is measured. For example, length of classroom can be represented as 10 meter. Here 10 is the number and m denotes meter, the unit in which length is measured. The standards are chosen arbitrarily with some universally accepted criteria. The arbitrarily decided and universally accepted standards are called units. There are several systems in which units are expressed such as series, centimeter for length, gram for mass, and second for time. FPS, foot, pound, second, and MKS is meter, kilogram, second systems. SI fundamental units. Length symbol for quantity is L. Name of SI unit is meter. Symbol for SI unit is M, small m. Physical quantity mass. Symbol for quantity is small m. SI unit is kilogram. SI unit is kg. Physical quantity time. Symbol for quantity T. SI unit is seconds. Symbol for SI unit is seconds. Physical quantity is electric current. Symbol for quantity I, capital I. SI unit is ampere. SI unit symbol is A. Physical quantity thermodynamics temperature. Symbol for quantity capital T. SI unit is Kelvin. Symbol for SI unit is capital K. Physical quantity amount of substance. Symbol for quantity N. SI unit name is mole. Symbol for SI unit is MOL. Luminous intensity is IV. SI unit name is candela. Symbol for SI unit is small c d. Physical property. Mass and weight. We know that matter has a mass. So mass is an inherent property of matter. It is the measure of the quantity of matter a body contains. The mass of a body does not vary as its position changes. On the other hand, the weight of a body is a result of the mass and gravitational attraction. The weight of a body varies because the gravitational attraction of the earth for a body varies when distant from the center of the earth. Hence, the mass of a body is more fundamental property than its weight. The basic unit of mass is in the SI system is the kilogram as given in table 1.1. However, fractional quantity gram is used for weighing small quantity of a chemical in the laboratories. Therefore, in terms of grams, it is defined 1 kg is 1000 gram is equal to 10 raised to 3 gram. SI unit. In 1960, the General Conference of Weigh and Measure proposed revised metric system called International Systems of Unit, that is SI unit. The metric system, which originated in France in late 18th century, was more convenient as it was based on the decimal system. Later, based on a common standard system, the International System of Units (SI units) was established. The SI system has 7 base units as listed. These are fundamental scientific quantity. Other units like speed, volume, density, etc. can be derived from these quantities. Length. Length in chemistry, we come across length while expressing properties such as the atomic radius, bond length, wavelength of electromagnetic radiation, and so on. These quantities are very small, therefore, fractional units of the SI unit of length are used for example nanometer, picometer. Here 1 nanometer 10 raised to minus 9 meter, 1 picometer is 10 raised to minus 12 meter. Volume. It is the amount of space occupied by a three-dimensional object. It does not depend on shape. For measurement of volume of a liquid and gases. A common unit, liter L, which is not an SI unit, is used. 1 liter is 1 dm cube, 1000 ml, 1000 cm cube. 1000 cm cube is 10 centimeter multiplied 10 centimeter multiplied 10 centimeter volume. SI unit volume is expressed as meter cube or m cube. Volume 1000 cm cube 1000 ml, 1 dm cube 1 liter. So 1 cube is 1 centimeter, 10 centimeter is equal to 1 dm. Volume is 1 cm cube 1 ml, 1 centimeter. Different kind of glassware are used to measure the volume of liquid and solution. For example, graduated cylinder, beer, pipette, etc. A volumetric flask is used to prepare a known volume of a solution. Figure 1.3 shows that the type of the apparatus used in laboratory for measuring volume of liquid. 100 ml graduated cylinder. Calibration mark indicate 25 ml volume. Value stop clock control the liquid flow. Calibration mark indicated 250 ml volume, 250 ml volumetric flask. These are the volumetric flask apparatus used in the chemistry laboratories. Density. Density of a substance is its mass per unit volume. It is determined in the laboratory by measuring both the masses and the volume of a sample. The density is calculated by dividing the mass by volume. It is the characteristics property of a substance. So SI unit of density can be obtained as follows. SI unit of density is SI unit of mass upon SI unit of volume, kg m3 or kg minus q. CJ's unit, it is gram per ml or gram per ml or gram cm minus q. Temperature. Temperature is a measure of hotness or coldness of an object. There are three common scales to measure temperature, namely degree Celsius, degree Fahrenheit, and K for Kelvin. Here K is the SI unit. Figure show the thermometer based on this scale. Generally, the thermometer with Celsius scales are calibrated from 0 degrees Celsius to 100 degrees Celsius, where these two temperatures respectively, the freezing point and the boiling point of water at atmosphere pressure, these are represented on Fahrenheit. Kelvin, Celsius start from minus 273.15, Fahrenheit start from 459.67. So, the temperature on two scales are related to each other by the following relation. Degree Fahrenheit 9 upon 5 degrees Celsius plus 32. Kelvin scale is related to Celsius scale as follow: degree Celsius plus 273.15.